All right, last but not least, we're going to talk about the average value of a function here. And so the average value of a function is given by the equation 1 over b minus a, integral from a to b, f of x dx. And that comes from the mean value theorem. If you're interested in its derivation, it's probably in your book somewhere, or you can come in and see one of the tutors. Your school will probably be able to help you with that. So I'm just going to go ahead and go straight forward with the formula here, because this is an applied calculus class, and the point is not for you to be able to derive this formula from another known formula. It's to be able to use the formula to find the average value of the function. So number 53 here, we have f of x is equal to 6x. We're given the interval 0 to 3, where the lower bound is my a, the upper bound is my b. So we're going to set this up 1 over 3 minus 0, integral 0 to 3 of 6x dx is going to be 1/3, and I'll go ahead and pull that 6 out while I'm at it. 0 to 3 of x dx. 3 goes into 6 2 times. This is 2. And then this is going to be 1/2 x squared from 0 to 3. The 1/2 and the 2 will cancel. And that leaves me with 3 squared minus 0 squared is 9 minus 0 is 9. So if I were to take all of this, 6x here, I'm just going to draw a picture this one time for you. And it goes from 0, 0, 0 to 3, 18. And I had all of this region right here. And I wanted to turn all of that area into a rectangle with the same area. So, but I want the same base here. So let's figure out what the area of this triangle is right here. I'll just do it with geometry. 1/2 of my base times my height is going to be 3 times 9 is 27. So I have an area of 27, but I want to change that into area of a rectangle, base times height. And my base is still 3. And my height is going to be my average value of my function. So 27 divided by 3 is my h, and that's 9, and that's what I got. I'm not going to do that with every single one of them, because triangles are pretty easy to find the formula for geometrically to just show you what I'm doing, but I'm basically changing that area into the area of a rectangle, and how tall would the rectangle be. That helps you visually see what I'm doing. So some stuff is a bit too big, some stuff is too small, but there should be just as much stuff that's too big as stuff that's too small in my average. It's not always going to be right in the middle. All right, f of the y value. So f of x is 4 minus x squared. And this is going to go from -2 to 2. And so we get the average value is going to be 1 over b minus a, integral from a to b, 4 minus x squared dx. This is 1/4, -2 to 2 of 4 dx. minus 1/4 of negative 2 to 2 x squared dx. That is negative 2 to 2 dx. The x from negative 2 to 2 minus 1/4 of x cubed over 3 from negative 2 to 2. This is 2 minus a negative 2 minus 1/12. 3 times 4 is 12 of 2 cubed minus negative 2 cubed. It's going to be 2 plus 2 minus 1/12 of 2 cubed is 8 minus negative 2 cubed is a negative 8. So that's 4 minus a 12th of 8 plus 8 is 4 minus a 12th of 16. That's 4 and 3. So that's going to give me 12 over 3 minus 4 over 3. When I make a common denominator, it's going to give me 8 over 3 for my average value of my function. Let's go ahead and look at number 59. Number 59 says f of x is equal to 3 over x plus 2. And my bounds are 1 to 5. And let's go ahead and evaluate. So 1 over 5 minus 1, 1 to 5, 3 over x plus 2 dx. Pull the 3 out. I have a denominator of 4, 1 to 5, 1 over x plus 2 dx. The derivative of x plus 2 is 1, so this is 1 over u du, but I don't need to do a u substitution here. I'll just use my basic rule, ln of the absolute value of the denominator. I'm going to evaluate from 1 to 5. So this is 3/4 of ln of 7 minus ln of 3. And I can't really do any better than that because those are all irrational numbers, ln of 7 and ln of 3, and they don't have any common factors like before where I could combine them into a single term. So that's the most exact my answer can get. I can get a decimal approximation for that if I would like to. With my calculator, I just need to know how many decimal places of precision I would need. So that's it for this section. We'll come back next time and start talking about, I believe it'll be 5.5. Yes, and 5.5 is going to finish up our discussion of chapter 5 for this course. So see you for the next video.